Welcome to Interface Studies. My name is Saleh. In 1963, Evan Sutherland completed a doctoral thesis at MIT describing a system called Sketchpad. It used a line pen, a vector display, and a constraint solver. A user could draw a line on a screen, and the line would behave as a line, like snapping to other lines, stay parallel, or even hold its length when others were dragged. The drawing answered back. 5 years later, Douglas Engelbart and his team at SRI demonstrated NLS, a system that included the mouse, hypertext, the structured outline, multi-window editing, and live collaboration with a remote colleague. Together, these two systems established something that had not existed in computing before. The user and the digital object could share a surface, in real time, in the same act. What preceded them was different. Computing in the 50s was batch. The user wrote a program on punch cards, submitted the deck, waited for hours or days, then received a printout that recorded what had happened. The user was elsewhere while the system worked. If you work with agents and AI, this may sound familiar. Now, Sutherland and Engelbart did not abolish that mode. Mainframes continued running batch jobs for decades. But what they did was open a second mode, one in which the user and the machine acted together. But this second mode became, over the next 60 years, the implicit default of consumer computing. Co-presence became what an interface was for. That word is worth holding. The user and the work in the same moment, on the same surface, at the same scale of attention. Co-presence. This video is an exploration of everything that follows. It's about how that default was named, refined, and then made into a doctrine, taken as obvious, and then, in the past 3 to 5 years, reopened on an axis the previous arc had not addressed. In 1983, Ben Shneiderman, working at the University of Maryland, gave this second mode a name. In an article titled Direct Manipulation, a Step Beyond Programming Languages, he identified 3 properties shared by the most successful interactive systems of the period. The objects of interest were continuously represented on screen. Actions on those objects were physical, performed by pointing, dragging, or pressing rather than typed as commands. Operations were rapid, incremental, reversible, and their effects were visible immediately. He drew examples from spreadsheets, full-screen text editors, and arcade video games. 2 years later, Edward Hutchins, James Holland, and Donald Norman, working at University of California, San Diego, gave the same idea a cognitive engineering account. Their paper, Direct Manipulation Interfaces, published in the Journal of Human-Computer Interaction, introduced 2 terms that have remained in use. Between a user's intention and the actions a system requires, there is what they call the gulf of execution. And between the system state and the user's perception of it, there's the gulf of evaluation. Direct manipulation works by narrowing both gulfs at once. The screen shows the world. Physical action changes the world. The change is visible without a second step. The interface, in their phrase, becomes engaging and first personal. It feels less like commanding a machine and more like operating on objects. What is interesting is that the next 40 years can be read as a sustained program to narrow these gulfs further. The Macintosh in 1984 packaged direct manipulation for a mass audience. The Xerox Star had got there first. The Mac sold. Photoshop made image editing direct in 1990. The web slowly became more direct. Form fields gave way to live updating pages, and live updating pages gave way to multiplayer documents. Touch screens replaced the indirection of the mouse with the finger. Multi-touch added the second hand. At each step, the distance between thought and visible consequence got smaller. Engelbart's earlier vision of augmentation was the opposite. He wanted humans to work through richer mediating structures, not fewer. The NLS demonstration was meant to show that a learned, complex environment could amplify intellect in ways a simpler one could not. Mark Weiser's calm computing argued that the most successful technology is the kind that recedes to the periphery of attention rather than commanding the center of it. None of these trends disappeared. Programmable environments, peripheral notifications, ambient displays, and tangible computing all kept them alive in research and at the edges of practice. But the dominant default for consumer software between 1984 and 2022 was direct manipulation. If a designer working on a piece of mainstream software in that period used the word intuitive, what they almost certainly meant was closer to the surface, fewer steps, more of the work visible at once, less interpretation, less waiting. In November 2022, OpenAI released ChatGPT. Within a year, a class of similar systems was widely available. The pattern that has stabilized across these systems and what followed is structurally batch computing with natural language input. The user types a prompt. The system thinks for some seconds or minutes, sometimes even more, and the user reads the result. The interface around this exchange has become familiar enough that its strangeness is hard to see. Direct manipulation made the user co-present with the action. Generative interfaces remove the user from the moment of action almost entirely. Three things shifted at once here, and they are often conflated. The medium of input changed from gesture and structured syntax to natural language, which lowered one barrier and raised another since natural language is convenient to produce but expensive to specify precisely. The medium of output changed from a computed value, where correctness can in principle be checked, to a generated artifact, where evaluation requires reading and judgment. And the duration of an interaction crossed that threshold. A response that takes half a second is a pause within an action. A response that takes 30 seconds is a turn within a conversation. A response that takes 30 minutes, of the kind that current agentic systems are beginning to produce, is an episode in its own right, with a beginning, a middle, and an end, and the user is largely absent from. The dominant interface pattern that emerged is version control applied to model output. The system produces a candidate. The user reviews it. The user confirms, rejects, or asks for another one. Diff views in coding agents, accept and reject buttons in writing tools, regenerate buttons under every chat response, the collapsed chain of thought summary expandable for inspection. Each of these is a way of letting the user remain authoritative over the output without remaining attentive to its production. The shorthand for the shape of this pattern is review, confirm, undo. This pattern is useful, but its limit is structural and increasingly visible. It assumes the unit of human attention can keep pace with the unit of agent action. When the agent's unit is a paragraph, this is true. When the agent's unit is a 30-minute run that touches 100 files or opens browser tabs, sends messages, and changes shared state, it is not. The user cannot review 100 things. Review, confirm, undo can absorb a few generations a session. It cannot absorb sustained autonomy. And the interface required for that, I don't think it's yet settled. So what is the design problem here? When the user is not in the room while the system acts, what does the interface owe them on their return? What is interesting is that there are several existing fields that have answered versions of this question, and their answers are worth taking seriously rather than reinventing the whole thing. Air traffic control is the most developed case here. A controller does not micromanage each flight in their sector. The controller's job is to maintain separation, anticipate conflict, and intervene at exception points. The interface privileges glanceable state over event by event narration. Decades of ethnographic work, beginning with studies at the London Air Traffic Control Centre in the early 90s, established that the controller's competence is not in tracking each plane, but in reading the whole airspace at once. The parallel theoretical work is Edwin Hutchins' Cognition in the Wild, published in 1995. It argued that cognition lives in the arrangement of artifacts as much as in any individual head. Let's talk about something else. Process control and the family of systems known by SCADA faces a related question in chemical plants, refineries, and power grids. The operator is responsible for processes that cannot be paused for review. The discipline that grew up around this includes alarm management, in which the catastrophic failure mode is alarm flooding, the situation where so many alerts fire at once that none can be acted on. The operator's interface is not optimized to catch every event, but to make trends, rates of change, and deviations from expected operations legible. Jens Rasmussen's framework of skill, rule, and knowledge-based behavior, formalized in 1983, and Kim Vicent's cognitive work analysis from 1999 are the canonical references. Computing's own operating systems already contain part of the answer. The Unix tradition has always assumed that processes run while the user is elsewhere. Daemons, cron jobs, background processes, the conventions of PS and top and tail-f, the design of system logs, all of this is interface for the receding user. It just was not, until recently, the part of computing that consumer software was modeled on. There's a small irony here. The forms required by current AI products are, in many cases, the forms that systems programmers have used since the 1970s. They were sitting in plain view. On the other hand, spreadsheets offer a different precedent. The user declares the relationships between cells once, and the system maintains those relationships afterwards. When the user returns to the sheet after time away, the values are current. This is the simplest case of a system holding coherence on the user's behalf, not an autonomous agent acting in the world, but it's a maintained model that stays consistent without supervisions. Bonnie Nardi's A Small Matter of Programming, published in 1993, argued that spreadsheets succeeded because they made formal computation tractable for non-programmers. And the maintained coherence property is part of why. Bret Victor's essay, Magic Ink, published in 2006, draws a distinction worth borrowing here. Most software, he argued, is treated as manipulation software, in which the user acts on the system continuously. Most software should be information software, in which the user reads and the system's task is to design the page well. When the user is absent during the action, what they need on their return is information software. Well-designed reading rather than fresh editing. Most current agent interfaces fail this test. They present the artifact of a long autonomous run as if the user were resuming a conversation rather than arriving at a site. At the end of all this, and if we wanted to look at it from a pure speculative perspective, grounded in all the material that we've discussed so far, it's that the agent interface of the next decade may look less like a chat and more like a cockpit, a persistent surface, with state, history, ongoing processes, deviations from expectation, and clear points of intervention. The chat input becomes one panel among several, used for instructions and clarification, but not for the bulk of the work. Observability tools in software engineering have already converged on something close to this from monitoring deployed systems. The cursor and Claude Code session views are early gestures in the same direction. Whether this becomes the dominant pattern is not yet decidable. The space is open, especially that we're still seeing attempts to preserve direct manipulation while augmenting it with AI assistance. Tools such as Clicky, alongside later research projects like DeepMind's AI pointer, explore the idea of an AI assistant pointer, keeping the cursor, selection, and visible interface as the primary site of interaction while allowing the system to interpret intent and assist within that same space. The arc that ran from Sketchpad to multiplayer Figma was about narrowing the distance between intent and visible consequence, on the assumption that closeness was the design virtue interfaces should pursue. The arc that began in the past 3 years opens that distance again, on a completely different axis. The new distance is temporal rather than spatial. The user remains in the room and on the surface. What they no longer share is the moment of action. Direct manipulation imposed continuous attention as the price for agency. To act on the work, you had to be there while the work was being done. The generative paradigm, specifically for coding or image manipulation, trades that attention for something else, not yet stable, not yet named with the precision Shneiderman gave to the previous default. The receding user is the working name for the position the new interfaces are designing for. And it is a position rather than a person, defined by absence from the moment of action and presence at its consequences. What those consequences should look like when the user arrives is the question the next decade of interface design will hopefully answer.